Why should you care about special relativity? Science and modern technology is incredible. Humans have spent centuries building our knowledge base to understand our universe. We interact with this world every single day. But if an alien landed on our planet and asked you why your world works the way it does, or how we developed our technology, would you be able to tell them? The extent of human knowledge is astounding and has allowed for the development of important technology and beautiful theories, but understanding this science is often inaccessible to the general public because it is locked behind bars of math and scientific jargon that only scientists can understand. This is frustrating and sad because learning science is satisfying and rewarding. The goal of these videos is to break those bars of scientific jargon and allow you to enjoy and appreciate these treasures, even if you haven't spent 4 years on your physics degree, thus freeing up knowledge to make it accessible to everyone. In this video, we will discuss Einstein's theory of special relativity. You have probably heard of Einstein. And if you have heard of Einstein, you might have heard of Einstein's theory of relativity. You might not know that Einstein's theory of relativity actually encompasses two theories, his theory of special relativity and his theory of general relativity. The broad theory of relativity states that the laws of physics are the same in every inertial reference frame. This essentially just means that as long as you are not accelerating, the laws of physics will not change. This sounds simple, but its implications are profound. From this claim, Einstein developed the theory of special relativity, which discusses the properties and laws of physics of objects moving very close to the speed of light. And to answer this question, Einstein came up with two postulates that would help us understand objects moving close to the speed of light. The first is the same as normal relativity and says that the laws of physics are the same in all inertial frames of reference. The second says that the speed of light in a vacuum is the same for all observers regardless of the motion of the light source or the observer. Okay, so what does that mean? Let's start with the first one. The laws of physics are the same in all inertial reference frames. Imagine you are watching your friend travel by in a rocket ship, and she is going close to the speed of light. This theory just says that you both experience and measure the same laws of physics, so gravity, light, and everything we observe follow the same laws of physics no matter how fast you are traveling. The second postulate says that the speed of light in a vacuum is the same for all observers, regardless of the motion of the light source or of the observer. Now this one is a bit more freaky, and let me tell you why it is so weird. If there were an apple flying through space towards you and your friend, who is still traveling in the spaceship, your friend would see it flying at her at a much higher speed than you would see it flying at you. But if there was a photon, and just like the apple it was flying at both of you, and you each measured its speed, you would measure the photon as having the same speed, which is freaky and doesn't make sense. But Einstein predicted it, and it is actually true. But why is that significant? Well, it is quite significant because of its profound implications. The first implication, Lorentz contractions. According to Einstein, if you were standing on the Earth watching your friend travel by at a speed close to the speed of light, you would observe some pretty spooky things. You would first observe your friend to shrink in her direction of motion, but you would also observe that time slows down on her spaceship, which is not shown in the picture. But if she were to pull out a ruler and measure herself, she would not think that her length changed at all, and she would not think that her time slowed down. This seems contradictory and fake, but it is true, and your GPS is proof. All GPS satellites use this theory of special relativity, and that is why they are able to work. Most people who know Einstein link him with his formula E equals mc squared. That's relativity. It says that energy and mass are the same entity, but they are different forms of each other in the same way that water and ice are different forms of each other. They are the same thing, but in different states. It also says that nothing can travel faster than the speed of light, because if an object were to travel at the speed of light, it would have infinite mass, which is impossible. This theory also indicates that time travel is probably physically impossible. To do so, you would have to travel faster than the speed of light, which is impossible even for the smallest particle with the smallest mass, and definitely impossible for you. So unfortunately, the only way to experience the world pre-coronavirus is through pictures and memories. What is the universe made of? Special relativity says a lot of wild things about space, but it also says a lot of wild things about time as well. Einstein's theory of special relativity says that space and time are connected. What does this mean? You are probably familiar with 3D space because you move through it every day. You can move up and down, you can move side to side, or you can move forward and backwards because of these 3 dimensions. But what you might not know is you are actually moving through a 4th dimension as well. And according to Einstein, that 4th dimension is time. You are moving through this dimension always, whether you want to or not. When you were walking to class last February, you were moving through 1 or more space dimensions, and you were also moving through time. When you are sitting in front of your computer on Zoom or looking through memes, you may not be moving through space, but you are still moving through the time dimension. The only thing that is different about the time dimension and the space dimension is you can move backwards in the space dimensions, but you can only move forward in time. Together, the space and time dimensions make up the space-time continuum. You may not have known it, but you live in 4 dimensions, time is actually real and not constructed by humans, and you move through it every second of every single day without knowing it. So there are many reasons that you should care about special relativity, but if the mathematical genius, physical complexity, and applications to technology aren't cool enough, then let me put it another way. Even if you don't matter, you energy. And you can look instantly thinner by running close to the speed of light. Want to fast forward through COVID? Buy a very fast spaceship. And most importantly, if you take one thing from this video, take this. You may think your life is going nowhere, but even if you are sitting on the couch, eating Cheetos, you will always be going somewhere, even if it is in time. And it's all because of special relativity.